All right, so the first thing you do is you make this graph by plotting points. Now I'm going to lead you through the process of plotting these points. You already have pictures of this on the blue sheets I passed out like last week, but I'm actually going to talk you through how we know what they are so you can see this. So as I go, plot these individual points. All right, I'm just going to grab a few points here and plug them in for x. So let's say x is -5. That means I'm doing this. You remember what those bars around it mean? Absolute value. Hopefully you remember that. If not, maybe make note of that. That when we put those bars around it, it means absolute value. And absolute value always takes whatever is on the inside and makes it positive. So if I'm going to do this, I'm basically taking -5 and I'm making it positive. Okay, so that's going to give us a +5. So x was -5, so I go left -5, and I go up 5 to get to my point. And so that's where we're going to plot our first point, at -5, 5. Now I just want to grab a couple of them, so let's go to -1. What is the absolute value of -1? 1. And so that means I'm plotting the point here, -1, 1. To plot that point, -1, 1, you go left 1, up 1. Next up, what if we plug 0 in? What's the absolute value of 0? Yeah, it's 0. Because there's nothing to make positive. It is just 0. Okay, now we really see if you got the idea of what absolute value really means. I'm going to take the absolute value now of 1. The absolute value of 1 is 1. Because remember, absolute value takes whatever's inside and it makes it positive. If it's already positive, it just leaves it positive. So let's go out then to 5. What's the absolute value of 5? 5. So that tells me to plot the point. 5, 5. You see what the shape of the graph is? We plotted at least enough points to hopefully be able to tell. I could actually plot tons more points, but we would end up just repeating the same process, where we take the absolute value and it just gives us the same number out, just it gives us that same number positive, which results in kind of that bounce in the graph that you see there. Because this side is all positives and positives. This side is negatives that give us positives out. Go ahead and sketch those lines in on your graph. Yes, they will be straight, so make them as straight as you can. This is our basic absolute value graph. Now, we graph this because if you can graph this one, you can now graph basically any absolute value function that I give you. I'm just going to give you a couple little tweaks and tell you what they do, and you're going to be able to graph them. Because every absolute value graph is going to be a V, just like this one was. So with that in mind, yes, there's our real graph, all formal and pretty. Please write this equation now above your next graphing grid. Now, as you look at this equation, what we know already is that it has the absolute value bars in it. Every time you see those bars in an equation, you should instantly now know my graph is going to be a V. That's the big idea here, is just saying every time you see those bars, you're going to get a V for a graph. Now we get into the details here. So the details on this, the x minus 2. Well, if you looked at your blue sheet, you'd be able to figure this out too, but I'm not having you rely on that yet. That -2 is actually going to move it sideways. Every time you have a number that is inside with x, it moves it in the x direction like this. And -2, well, it's slightly annoying. It goes opposite from what you might think. X minus 2 goes right 2. All right, so I know that I should have a graph that's a V, but my V is not going to be starting here at 0 this time. It is instead starting right 2. So I put my first point right 2. By doing that, I've used the minus 2. So from there, it's the exact same graph as what I did before, which means that from that point, all I need to do is go over 1 and up 1 on each side. Because remember, that's what I did on that first graph. If you don't believe me, take a look at that first graph you made, and you'll see we were always going over 1 and up 1 from that starting point. It's just that in the first one, the starting point was at 0. And in this one, the starting point's over 2. Notice the beautiful part is, I didn't have to plug in a bunch of numbers this time. I only did that with the first one so we could see what they do and what they do to the graph. All right, so we're now graphing this equation. So we got y equals the absolute value of x plus 3. Notice the difference between this equation and the last one. The plus 3 is outside of the absolute value. That changes what it does. Because when it was inside, it moved the graph left and right. When it's outside, it moves it up and down. Now, when it was inside, it was kind of weird because minus went right, plus goes left. When it's up and down, it happens the way you think it should. So a plus 3 is going to move it up 3. Now, what impact does that have on our graph? Well, instead of having a V-shaped graph starting at 0, 0, and again, this is where your brain starts with this. Your brain starts with seeing the graph at 0, but then we move it from there. And I'm moving it up 3. So my first point is actually going to be here up 3. And only up 3, because this one wasn't moved over at all, so I'm only going up 3. I plot that point, and then it's the same graph as what we would normally do. And so from that point, I go over 1 and up 1 on both sides. And I just keep following that pattern to get all of those points in on both sides. And yes, I do need you to be accurate about that. That's why we're doing these on paper, is because I need you to be able to see we have to follow this pattern of over 1, up 1, over 1, up. If we just did these on the computer, we would tend to get a little bit lazy. We would remember where we put the first point and the second point, and that would be it, because that's all you need when you do it on the computer, because it builds the rest for you. On these, I need you seeing what all the rest of them do. All right, last one of the absolute value graphs we're going to practice right now. So go ahead and copy this equation above your next graphing grid. And then before we do it together, see if you can make that graph on your own first. So in order to make this graph then, we have two numbers involved. We have the plus 4 and the minus 1. We cannot combine those into a single number. We have to deal with each one separately. They both have different effects. Okay? The plus 4. The plus 4, it is in with x. Therefore, it moves it in the x direction, left and right. Plus means left. And so we're going to be moving our first point left 4 and the minus 1. The minus 1's hanging on the end. Therefore, it's going up and down. Minus 1 is going to go down 1. Oftentimes, drawing those little arrows around your equation are a great way to keep track of what you're doing on this. So now, that tells me to go left 4, down 1, and plot a point right there. Once I've plotted that point, the rest of the graph is hopefully easy because it's making the exact same graph we've made every single time. That is, you plot the first point, and then you go over 1 and up 1 on both sides to get a V. We know it's a V because it's absolute value. So we're shifting now into a new type of equation. First of all, if you had your blue sheet, you would look at the top and you would see the word on this at the top of quadratic. Because this is a quadratic equation. Anything that starts with an x squared is called quadratic. And if you were looking at the blue sheet, you'd know that it was a general U-shaped graph and stuff like that. But that wouldn't necessarily tell you why it behaves the way it does. And so that's why I want to show you here and get you an idea about why is it a U. All right, so in order to do this, again, I'm going to grab some x values and plug them into the equation to see what y's they give us. And I'm going to actually write this one as a table just to make it a little easier to see which numbers go in and which numbers come out. So I'm going to grab a nice starting x value. How about an easy one? What about 0? If x is 0, well, what is 0 squared? Well, remember, squaring something means multiplying it by itself, so that's 0 times 0, and 0 times 0 is 0. That's a lot of zeros. But that's why this graph starts at 0, 0. Just like the last one did. Easy to remember. Okay, next one. Let's grab an x value of 1. 1 squared, that means 1 times 1. And 1 times 1, yes, is 1. And so that tells me to plot the point 1, 1. Now, if we assumed that 2 points was enough for a pattern, some of you might start drawing in the exact same graph that we just made before. But that wouldn't be right. Because while these first couple points are often the same, they are often at 0, 0, and 1, 1, things start changing drastically after we get past 0 and 1. So let's take a look and see what happens at 2. What's 2 squared? 4. And so then I plot the point at 2, 4. Notice that I went over just 1, but I went up much more. That's why this starts creating a U shape instead of a V shape. It's going to be going up, but it's going up faster and faster the further we go out. Okay, let's plot at least one more point on the right-hand side there. Let's go to x equals 3. What's 3 squared? 9. Yep, because it's 3 times 3 there. So we're going to go to the point 3, 9. Count it out. All right, so we've already seen a lot on the right-hand side here. Now, I've already told you that it's a U-shaped graph. But why? Why is it going to be a U-shaped graph? Well, let's actually plug in a point and see. Because otherwise it might look like it's supposed to go down here. But I want you to see the math behind it. So let's plug in -1. We're going to be doing -1 squared. Now, don't rely on your calculator for this. Half the calculators you type this into will require you to put parentheses around and all that for it to be right. You should know this off the top of your head. Because if we're squaring it, we're multiplying it by itself. Therefore, we are doing a negative times a negative. And a negative times a negative is a positive. That's why it's positive. All right, now with this one, first of all, what shape will this graph be? It's going to be a U. I know that because I see the squared. Anytime I see the squared, I'm drawing the U-shaped graph. It's just a matter of where do we start with it? The -3 is inside with the x. Which way does that tell me to move it? To the right. And so I go to the right 3 units. Now that I know that's my starting point, I'm going to draw the exact same graph that I just made for x squared. Remember how we made that? I went over 1 and up 1, but then I went over 2 and up, what was 2 squared again? 4. And that's how I know. I'm going over 2 and up 4 because 2 squared is 4. And I'm doing this on both sides as well. So then, what if we go over 3? I need to go up how far? 9. And that's going to give us our shape. Go ahead and draw the curve that goes through them. All right, so we've got the hang of this now. Let's apply it to this situation. The minus 2, notice it is not in parentheses, it is not in with x, therefore it is going up and down, specifically down, because minus goes down. So I put my first point down 2. Once you have that point, I know I'm just drawing the U shape, again, because it's squared. Anytime I see that squared, it's a U. And so then I go over 1, up 1. And then from my original point, I go over 2 and up 4. And then from my original point, I go over 3 and up 9. Because I'm always just remembering that I square whatever I go over. And that tells me how far to go up. Once you've plotted those points, then you just draw the graph that goes on. Yes, I do want you extending your graph, please, to the edge of the graphing grid. So draw in this part, please. You want to draw it in as neatly as you can. So on this last one, certainly it looks more complicated, but it's following the same pattern. It's got a squared in it, therefore it is a U. It's just a matter of which way we're going. The plus 1 moves it left 1. Remember, if it's in with x, it goes sideways. Plus is left, minus is right. Plus 3, that goes up and down. Specifically, it goes up 3. So I put my first point left 1 and up 3. Once applied that, it's the same old pattern that we were just doing in all these other ones. I go left 1, up 1, and right 1, up 1. Then I go over 2 and up 4. And then I go over 3 and up, wait, I can't go up 9, can I? Okay, so then I just can't plot that one. It doesn't fit on. And so then I can go ahead and draw my graph in from there.